This is lesson 1.2, absolute value. The absolute value function f of x equals the absolute value of x is a function that returns an output that is non-negative, which means if you were thinking of the numbers on a number line, this function describes how far away f of x, or any number, is from the origin. So for example, if we start with the number -3, we would count back to 0 to see how far away it is from 0. So 1, 2, 3. That means that the absolute value of -3 is 3. Similarly, if we start at +3, we would count back to the origin 0, 1, 2, 3 spots, which means that the absolute value of 3 is 3. As well, by definition, the absolute value of 0 would be 0, because it would be 0 spaces from the origin. The graph of the absolute value function is something that we saw last year in grade 11U, and we can complete the table of values by counting how far away each x is from the origin, or by turning it into a piecewise function. If x is greater than or equal to 0, then the output, f of x, is just that same x, 0, 1, or 2. And that's why f of x is the same as x for numbers that are equal to or greater than 0. For numbers x's that are less than 0, like -1, -2, -3, we could use the negative x, or sorry, f of x equals negative x part of the function, and change the sign of our input x to get our output f of x. 3, 2, and 1. To make it as simple as possible, the absolute value function takes away any negative signs and just gives you the value associated with x. So 3, 2, 1, 0, 1, 2, those would be your f of x or your y values. If we draw the graph, we get a nice symmetrical graph. 0, 0, -1, 1, -2, 2, -3, 3. And on the positive side, we have 1, 1, 2, 2, 3, 3. And if we connect those, we get a V-shaped graph. We can extend a little bit. And this is the absolute value function. Or sorry, the graph of the absolute value function. Some common properties of the absolute value function, I'll try to keep the picture on there as well, is that there is a 0 for the graph, and it is located at the origin. The graph is symmetrical, as I stated earlier, but it's symmetrical around the y-axis. As x approaches large positive values, that means as x goes to the right, what's happening to the graph? Is it going up or down? The graph is going up as we go to the right, so therefore the y's would be increasing as well, or approaching large positive values. As x approaches large negative values, so as we go to the left and we start to get more and more negative or larger negative values, y is still going up, so it's still approaching large positive values. They're both the same because, well, the graph is always above the x-axis and y is always positive. The domain of the absolute value function, if you look, anything to the left and anything to the right, and we're connected with a line, so that means there are no restrictions on the domain of the absolute value function. So our domain would simply be x belongs to real. Our range, however, does hit 0, but only goes up. It doesn't go below 0. So the range of the absolute value function would be f of x belongs to real, such that f of x is greater than 0. That's it for the lesson 1.2, absolute value.